Hello everyone. Today we are going to discuss empirical formula and their relationship with molecular mass and molecular formula, right? So in previous video we have learned about the atomic mass unit as well as mole concept and their relationship between the what mass and the number of particles of the substance, right? So today we are going to discuss about the empirical formulas, guys, right? You may have heard of the empirical formulas in your NCERT books as well as many places, right, in 11th standard. So let's talk about what the empirical formulas, right? So empirical formula is nothing but it denotes simplest proportion of the number of atoms of elements in a compound, right? So what it denotes, the key point here, guys, let me write down the key point. So you need to always focus on the key point, guys, right? See, don't focus on general definitions, guys, right? So always try to focus on the key points. So I'll tell you some tricks and techniques how to focus on the key points, guys. So let me show you here. So here, guys, what is the key point here? The key point here, the proportion. Proportion of what, guys? The number of atoms, right? So I'm marking it like proportion. So here the proportion. And of what, guys? Number of atoms of element in a molecules. Or general term we can say the particles, guys, right? Of substance. Okay, guys, so here what is the key point here? Proportion and the number of atoms, right? So now first we need to define the proportion, guys, right? So you may have studied in your 10th standard or maybe in 11th standard, right? What is the proportion? So we are talking about the two thing here, guys, the proportion, guys. So let me define you proportion. And I'll tell you the interesting thing here also, right? See, all of you know the proportion, but just to remember, right? See, you may have heard of, right, empirical formula, empirical mass or molecular mass equals to n times into the empirical mass, right? This you may have heard of it, right? So anyway, we'll try to prove it today. We'll prove it today, actually, right? So, but before that, let me start 1 or 2 minutes with the proportion, guys. This is very key point here. Let me tell you again, one who knows it, they can move forward with the videos. The one who don't know, try to understand this one, okay? So let me go ahead with the proportion, guys, okay? So the proportion of A, B, C, you denote by A colon, B colon, C, guys, right? Now this one you denote by this one. Now here, in proportion what you do, you are taking common, right? Common everything. Whatever the common is there, that you removing it, and then what the integer comes, you are showing in that proportion. So let me show you after removing this, assume it's x colon y colon. So here, guys, remember here. So you can write down A might be k into x, B might be k into y, and C might be k into k. Why so? Because I told you, guys, when you write down the proportion, whatever comes, right, whatever the commons you are taking out of it, right? So it means something common you have taken. So from everyone you have taken something common, just assume like k. So you can say A equals to k into x. So B equals to what? The k into y, because you told after removing some common thing, you wrote this one, right? So this is the one, guys. So this one, many of you might be knowing it. One who don't know, kindly try to note it down. But let me tell you more interesting thing right now. More interesting thing will come here right now. What is the K actually? So I think around 99% student will not think about it. What is the K? They'll simply assume, oh, it's some number actually, right? So you'll say some constant, right? But let me tell you that is SCF, guys. What you can take the maximum out of the maximum common thing you take from something, some 3, 4 number or 5 number. That means what? You are talking about the highest common factor. So what is the highest number which is common among all, right? So that means the CF, guys. So the K will be what, guys, here? The interesting thing here, guys, is CF of what, guys? A, B, C, guys. So this is the thing you can say, this is a fire in mathematics, right? You can say that, right? See, this one, I think you have not thought of it, right? So right now we are trying to find out logically or mathematically like how we can make it chemistry easy actually, guys. So the interesting thing I'm bringing you guys actually. So now you see here, K is the what? HCF, guys, of this one. So now this is the one, guys, you know the proportion and how to calculate the proportion. So next time if I'm telling you to calculate the proportion, what you'll do? You will simply take the HCF of all the numbers and then you divide each number by that HCF. Whatever comes, that will be giving you what? Proportion, right? Now here, guys, this is a very important thing here, guys, this one. Now let's go about the second point, the number of atoms, right, of elements, right? So empirical formula is nothing but what it denotes, the simplest proportion of number of atoms in a molecule of the compound, right? So that means we are going to show now the formula of that one, like the empirical formula. What could be the empirical formula? Now you know the simplest number is what? Simplest proportion x colon y colon j. Now we can rewrite the molecular formula in terms of empirical formula, right? So let's write down that one, okay? Okay, guys, so kindly pause and try to note down this portion. Okay, guys, so now let's try to derive the formula, guys. Now I'll tell you in mathematical form what it could be, guys. The empirical formula. So we can say A is the symbol of element A. So AX, BY and CZ. Because you know, right, now X colon Y colon Z, this is the proportion, right? Proportion value. So now in terms of that, the empirical formula represents the molecules, right? So this is the empirical formula now. Okay, and now the relationship, one more interesting thing is here, like note down this one, this relationship here. So what is X, guys? A divided by HCF A comma B comma C. Y, you can say B by HCF A comma B comma C. And Z, C by HCF A comma B comma C. So this is, if you have given right the molecular formula, you can calculate x, y, z this way, and then you can derive the empirical formula, right? So how easy, right now, right? How it could be easy, right? If you know the molecular formula, simply you can derive it this one x, y, and z by using this formula. And important thing, you know the proof also, right? How it comes, right? So that's interesting here, right? So let me write down the empirical formula, guys. So empirical formula, this is the formula, guys. How to calculate x, y, z? If you know the molecular formula, this is the formulas, guys, right? So I hope this is interesting, right? You may have not used this one, right? You may have taken the common, right? Because generally number will be given 1 or 2, 3, right? Sometimes they are giving you in a variable format. In IT, then they are going to ask you in variable format, then what you will do? Then what will you do? At that point, this will be the interesting, guys, right? So this will be like what? One who has the fire in belly, those guys will try to use this one actually. They'll try to derive in terms of the mathematics, guys, because sometimes the IIT will give you something in mathematics, right? So IIT have still not explored this one, like chemistry in terms of what? Mathematical aspect of it, right? But in future you may see this one as well. So let's go ahead, guys, try to find out one more important thing here, the relationship between empirical mass and the molecular mass. What is the empirical mass, guys? So empirical mass, of course, is what? The mass calculated from what? The empirical formula. And the molecular mass is what? Mass of the one molecule. So you know, right? That one. So anyway, let's try to find the relationship. Empirical mass and molecular mass, guys, right? So you know the formula, molecular formula, you know, and empirical formula, you know, we can calculate easily, right, the empirical mass. So we can say empirical mass. Empirical mass will be what, guys? The formula you know, AX, BY and CZ. So X denotes what? Number of atoms, right? Of X into the one atom, what the mass? We denote by A stand for what? Atomic mass, and A stand for the element A. Plus Y into A stand for atomic mass, B stand for what? Subscript for the B element, right? And get into A, right? So this is what we can say as empirical mass, right? Now let's try to write down the molecular mass, right? And now it's easy, guys, straightforward, right? So let me write down the molecular mass, guys, and then you will be able to see easily the relationship, right? Which you remember long back actually. So we know, right, what the molecular formula we assume it? AA, BB and CC. Means what? A number of atoms of element A, B number of atoms of element B, and C number of atoms of element C, right? So A plus B into A B plus C into A C, guys, right? Now see, we know this in terms of this one, right? The atomic mass of element, the relationship, and we know the relationship between what, guys? A and X also, right? A and X, and then Y and B and C and Z, right? Now we can easily find the relationship right here. So we can try to put right this one, A values. So A value will be X into HCF, right? So we can say X into HCF A B C plus Y into what, guys? This one, A atomic mass will also come into the picture, right? So Y into HCF A comma B comma C into AB plus Z into HCF, guys, X A comma B comma C into AC, guys, right? Okay, so now one more step and we are done. So guys, now molecular mass. Okay, not right. Okay, so now see here, HCF is common. So HCF A comma B comma C, X into AA plus Y into AB plus Z into AC. Oh, what you got this one here? This is what? This is the empirical mass, right now here. So let's write down here HCF A comma B comma C into empirical guys. So you know, right, we are able to drag now the relationship between this one. If you know what, if you know that generally this number, if they gave you this number and they gave you the empirical mass, then you will be able to calculate the what? Molecular mass. And sometimes they'll give empirical formulas and they'll give you the number here. You can get what? You can get the molecular formula also, right? So this is the one very, very important thing, guys. This whatever we derived it, this is a very, very important thing. This we are going to use in where? The determination of empirical formula and also determination of what? Molecular formula. We'll tell you in the next video how we can use this one, this formula. This is very interesting, very easy, very interesting, and it will be used in many places actually, guys. So thank you for watching this video. Kindly try to comment, try to let us know like what you want actually from us, right? Kindly subscribe and kindly share it, right? And try to spread this message, right? Like, because we'll be giving you, of course, that this one, this will be completely free, guys. There are no charges for you guys, right? So it will be beneficial for others also, right? Who don't know, who do not have access to that highly paid course, right? So kindly refer to them. Thank you very much. Thank you, guys.